Hi, this is Michael King. In this final video, we're going to look at ex ante return and risk for a stock, which means what we forecast or we expect in the future. This is going to be sections 8.1 and 8.2 out of Booth, Cleary, and Rikita. So recalling that we're in the present now, we've been talking so far about the past or ex post. Now we're going to talk about the future or ex ante, meaning what do we predict? And this is going to be a tool we're going to use when building our portfolios. In finance, we spend a lot of time talking about expected returns, which are called forecast, predicted, or ex ante. To do this, we're going to use a different notation. We're not going to use R for return because we don't know what the return is. We're going to use expected return or ER. And what we're going to do is we're going to have to assign a probability or likelihood based on different scenarios, where for each scenario, there's going to be an expected return for a stock. We're therefore going to calculate the expected return by taking weighted probabilities, where you multiply the probability of a scenario times the expected return in that scenario, and you add them up. So let's say a stock A has a 50% probability of going up 10% and a 50% probability of going 5%. What is the expected return? Well, you can see that in half the states of the world, you're going to earn 10%, and in half the states of the world, you're going to only earn 5%. So we would expect it to be somewhere in between. And sure enough, the weighted expected return is going to be 7.5%. It gets more complicated when you look at three different scenarios. So here we're going to look at three different states of the world for a given stock A. We're going to have a high growth scenario with a 40% probability where the return is going to be high at 10%. We're going to have a no growth scenario with a 40% probability where the return is 5%. And we're going to have a recession scenario where with a probability of 20%, the expected return is going to be 1. So what's the expected return? Well, you multiply the probability times the return in the state and add them up. So 40% of 10, 40% of 5, 20% of 1, add them up. The expected return is going to be 6.2% across these different scenarios. We can also do the same for calculating what the expected risk or the expected standard deviation would be. It's a little harder. It requires more math, but you can see the formula on the left. Again, we have the probabilities, we have the returns, and now we know what the expected return is. We calculated it at 6.2%. So what we're going to have to do is we're going to have to use this formula where we look at the deviation of the expected return from its arithmetic mean. So in the high growth scenario, 10% minus 6.2, we're going to square that and we're going to take that with a 40% probability. We do the same again for the no growth scenario. We expect 5%, but the arithmetic mean across the different scenarios is 6.2, so a negative number. We square it and take 40% of that. And in the recession scenario, we take 1% minus 6.2, square it to make it positive, take 20% of that. We add up those numbers and take the square root, and we see that the expected standard deviation is 3.43%. So this looks pretty good. The expected return is 6.2. Coefficient of variation is going to be very, very small at around half. This looks like a good set of scenarios. Okay, so let's look at some other examples. Here's a stock B. Here we have the probabilities, we have the returns, and you need to calculate both the expected ex ante return and the ex ante risk. Okay, what do? Well, first you have to calculate the expected return. Okay, remember it's the probability times the return in that scenario, and you add them up. So if you were to do that, you would see that 40% of 7, 40% of 4, 20% of 2, added up would be 4.8%. Okay. Now to get the expected standard deviation, remember you're going to have to take deviations relative to the arithmetic mean. You're going to have to square them, multiply by the weights, sum up those weighted squares, and take the square root. Here it is in notation. 7 minus 4.8 in squared with a 40% probability in the high growth scenario. 4 minus 4.8% squared with a 40% probability in the no growth scenario. And 2 minus 4.8% squared with a 20% probability in the recession scenario. Taking the square root, we see that the standard deviation is expected to be 1.94%. Obviously, it only makes sense if you believe your probabilities and your expected returns. But we can see again that the coefficient of variation is below a half, 1.94 divided by 4.8. So this also looks like a very good set of scenarios. Let's look at another example, but this time we have two stocks C and stock D. Which one do you think is going to be a better? Well, just looking at them, stock C looks like it's going to have a higher high, also a lower low in the recession scenario, whereas stock D is going to be much more stable, hovering between 4 and 8% per year, depending on the scenario. Which one's going to be a better deal? Well, the expected return, if you were to do the calculation, is 7.4% for stock C and 5.6% for stock D. Does that make sense? Yes, if you think about it, if you look at the range of values and the probabilities, you can see that, 7.4% is somewhere between 1 and 15, and 5.6% is somewhere between 4 and 8, closer to the middle. How about the standard deviations? Well, if you just look at it, you can already see that stock C has a higher standard deviation than stock D. If we calculate it, sure enough, stock C has a standard deviation of 6.25% expected. Stock D has a standard deviation of 1.5% expected. If you were to simply do the math in your head for the coefficients of variation, you can see that for stock C, 6.25 divided by 7.4 is going to be around 0.8, 0.9. For stock D, it's going to be 1.5 divided by 5.6, which is going to be around a third, or 0.3. So from a coefficients of variation point of view, stock D looks like a better deal.